All right, so, we're getting back to the troubleshooting. Now, if the most common call is ignition failure, and that's pretty much on, any fan-assisted product is you might get that from time to time. And talking about like a 111 code, but you said that there could be a couple of other codes associated with that.
Yeah, 111 code. Well, let's talk real quick just about the sequence of operation, because that's important. So first we see the flow. We need at least half a gallon a minute of flow before this even tries to fire.
Right.
When we see the flow come on, we'll bring the fan on. We're measuring the RPM of the fan, so we know that the fan came on. We'll try to spark and open the gas valve, and we'll get a flame, and we get the flame, and then we heat all the way through.
Okay.
So 111 error code means that it tried 3 times to see the flame. So we got the sparking and opening a gas valve point of it, and we never saw the flame.
So we never saw the flame on a 111.
So 121 is just like that, except we were in a heating cycle. We had a flame, but for some reason we lost the flame, and then 3 times in a row we couldn't relight.
Okay.
So same thing, just kind of different in the timing.
Okay.
This is a really easy trouble code to troubleshoot. The first thing and the easiest thing is turn the power to the water heater off. And we could try it here. I'm not sure if they'll be able to hear it. Probably so, because that's pretty loud.
Yeah.
You're going to let it sit off for about 5 seconds and then turn it back on. And that just gives the control board time to de-energize.
And we're going to listen.
So hopefully you guys got to hear that. So there's 3 sets of clunk clunks. And what that is that's the 3 stage sections of the gas valve testing themselves, opening and closing. So if we don't hear the clunk clunks, we're going to wind up with another error code. We'll talk about that after we finish 111.
Okay.
But if we hear the 3 clunks, we're good to go to the next step.
All right.
An ignition failure means that the control didn't see a flame. It doesn't exactly mean that there wasn't a flame.
Right.
So we want to take a look here through the sight glass and see, did we light? Do we have
Yeah, we're either going to light or we're not, right?
Right.
So we're going to look through our sight glass. We've already heard the clunks. We look through the sight glass. It's either going to light or it isn't.
Okay. Now, if it does light, so we get a good brief blue flame, 2 to 3 seconds, a solid flame, we don't have to worry about gas, air, or spark, right?
Right.
All those things happen.
It did because it lit.
So we're looking then at the electronic side of things.
Okay.
Pull the flame rod first, clean it with some steel wool or Scotch-Brite, something abrasive that's going to polish that up. While you've got that out, look for any damage. If you see any cracks in the ceramic, go ahead and replace it. If any of these rods spin freely,
Right.
go ahead and replace it.
Because you can do that, especially if you didn't press the locking the locking spade and just pulled it off.
Right. So in that case, go ahead and replace them. If
So that's if I did see a flame, a brief blue flame, and it goes out, I'm immediately going to go here and clean off my flame rod.
Yeah, we know it's electronic. We know we had the flame. The
Yep.
control board just couldn't see it.
Okay.
Now, also when we do that, and I'm going to take this off again for just
hold
a
it.
second. We've got the flame rod ground is right here, so we want to check and make sure that we've
Very
got the ground connected and that it's a nice tight connection. And we'll unplug it from here, and we'll unplug these connections also. Just plug them back in. By doing that, it cleans the connections.
Okay. All right. So go ahead and turn it now. So it clean. So go ahead and take these off, put them back on. You're going to clean the connections anytime. Even unplug it, right?
Right.
And plug it back in.
Unplug them, plug them back in. There's a self-cleaning connection, so by doing that, we remove enough material that we get a good, clean electrical connection to make sure that we're getting the signal. We can pick the signal up here, and we're getting a signal back to the control board.
Okay. And that's if it did light and it goes out, because it has what, 4 or 5 seconds to see the flame. 4 seconds. To see the
About
flame.
4 seconds to see the flame, and it will try 3 times again before it does that. So you're just going to look through there. If it did light, we know it's electronic.
If it didn't, then we know we've got air. I mean, because there's air in here, but there's one case it might not do that. But I'm just saying that there's air, and you've got a spark. If it's sparking, that leaves the other thing on the fire triangle, and it would be a fuel.
Right. Well, first thing that you want to do is check the spark. So we'll slide the little boot back. We'll pull this off, and just like we would with a spark plug, we're going to hold it close to while it's trying. If we see the spark,
It'll work. Now, can you see the spark when you look in there? Did you just
No.
shock yourself? I was like,
I couldn't
can you
get it
see
lined up.
Can you see the spark when you're looking in there?
Depends on the location where you're at and what's going on. Sometimes you'll be able to see it inside of there.
If it's dark in the room,
If it's dark in there, but if it's a really bright room or maybe it's got a lot of dust in there, just by pulling that off and holding it close to the cage, you'll be able to see it spark across. Let's see if I can get it on there. Got it that time.
And this is if it didn't light. I mean, it tried 3 times and it did
Yeah.
not light. You had spark. We know we have air, so that the only thing really, it has to do something with the gas.
Has to do something with the gas. So, and this is easy. We know that the gas valve worked because we did the 3 clunk clunks.
You heard it.
So we tested that. So when we're checking for the gas, where's our manometer?
Right.
Okay. So what we're going to do is down here at the bottom at the gas inlet.
I don't know if we can get a shot of here, Heather?
We have to lift it up.
I'll lift it up. Whoa, did it come on?
No, we're good.
I don't want to drop it. Right there. If I had a light, I don't have, there it is. See, it has a piece of tape on it that does say gas.
So at the gas inlet, there's a screw right here where my thumb is, and it doesn't show very well. I'm sorry about that. But we take that screw out, and that gives us a port where we can actually hook up our manometer.
Okay.
So we're just going to slide our manometer hose over top of that stub that's sticking out. And if we have gas, that's great.
Yeah, that's good.
All right, because we've already tested the gas valve. We know the gas valve is working.
Right.
So check the spark.
Right.
We got spark. Now, if we have gas to the water heater, now it is an air problem. I know that we said that because the fan was running, we had air.
Right, yeah, but...
Jerry kind of tricked you.
Yeah, well, listen, I mean, if you got gas there, but, you know, there could be a chance that you have air in the gas line as well.
It could be.
That's another thing. You may have the pressure there, but it's a brand new installation. If you're doing that, you are going to put air in that gas line if you've had to break that and install that. So you're going to have to get that air out of there before it's going to fire. In that case.
Yes.
But there is one, and I knew where you were going. It could be air. Now let's talk about that.
It could be air. Now, we know the fan's running.
Right.
But we don't know if we're actually moving air. We just know that the
Exactly.
fan is spinning because we're looking at the RPMs.
Yes.
So we want to check the intake and exhaust just to make sure that we don't have any blockages. But if we have gas and we have spark, there's a tube right here that connects the burn chamber
Now,
down
see,
to the gas valve.
this water heater has no pressure switches, and well, in a traditional pressure switch sense, most tankless water heaters don't use them. But this, what you're about to talk about, you're describing a pressure switch.
It's a mechanical pressure switch
Yeah.
instead of an electronic pressure switch.
It's really cool.
So if there's a blockage here on our coil
Mm-hmm.
or a blockage in the exhaust, when the fan is on and it's blowing air up in there, the air can't go anywhere. So pressure just builds.
Exactly.
So it transfers down this tube, and there's a diaphragm in the gas valve that tube pushes against, and it won't let any gas come out.
Yeah.
So-
So it acts as a pressure switch. It will not let it fire. You'll probably end up coating out on a 111. Yeah.
Yeah, you'll code in on a 111, or if it happened in the middle of a cycle,
Yeah.
a 121. So
But on that sense, you'll just need to get rid of the blockage, and if you have to, you need to clean the burner. It's easy to get to. You just have to remove a couple of parts really to get to that burner. It's real simple, and you can blow it out with compressed air. You can use a degreaser if it's really, really dirty, like 409 Simple Green, and clean that. Use soap and water if you want to, but just one thing before you put it back in, make sure that you kind of get it as dry as possible. You don't want it sopping wet going back in there.
yeah, exactly. We don't want to drip any water on any of the electronics. Now,
Exactly.
you'll see that the electronics are pretty well protected from any kind of, and maybe occasional drip as we get from servicing, but we still don't want to take that chance.
But let's rule all that out. If it is gas, then that's where we're going back to where the sizing was very important on the gas line. So you're going to need to use your manometer, and you're going to need to test that static pressure where it's just standing still, it's not running, and then you're going to want to fire the unit and see how big a drop you have, right? But not only do you fire this, you fire everything that uses gas.
Yeah, you want to fire all of the appliances, so the furnace, the oven, the range.
And that's why when I said, you may install it in the summertime, and in the wintertime you're having problems. Well, that makes all the sense in the world because you just turned on 140,000 more BTU or 200,000 more BTU on your furnace.
You're now competing for gas with another appliance, and the other appliance doesn't care.
Yeah, it doesn't.
If we don't get enough gas, it'll just burn at a little bit lower input. Our water heater does care because if we don't get enough BTU input, that's going to affect how much hot water we get out as far as flow. So.
Yeah, and that's the cool thing about this. This is going to see that. It's going to try really hard to adjust if you're lacking in that gas. It will adjust that fan to meet the gas. But like I said, if it gets to a certain point where it can't do any more, and if it's over that 1.5 inches, and we don't want to see 1.5 inches drop on any of our appliances. I mean, anything over that. But it's going to get to a certain point where it can't do any more, and it's going to tell you, or it's going to lock out eventually. It just won't fire.
And that actually goes into our second most common code.
Yeah.